Hello, this is the raft problem, the raft with two swimmers. So you've got a raft that's just sitting there, and see if I can draw a raft really nicely for you. There you go. There's a raft, and we'll make this the 50-kilogram swimmer jumps off on the left side, and a slightly more mass 80-kilogram swimmer jumps off on the right. I'll make that box a little bigger to represent that. And before the collision, it says the raft is initially floating at rest. So before the collision, nothing's moving. Whoops, I don't want to move that. After the collision, so let's clone that, and I'll move all this over. Okay, and probably be good if I move this over. Move this way. Okay, and I'll move this stuff here a little bit. And one swimmer jumps off one way. All right. Another swimmer jumps off this way. Okay, so this is before the collision. Nothing's moving, so velocity equals 0. Therefore, the total momentum equals 0. So that's before. After, we have this swimmer moving to the left, this swimmer moving to the right, and part of the question is, which way is the raft moving? Pretty cool. Let's see what we know. Well, we got a momentum. Let's call this the 50-kilogram swimmer on the left and the 80-kilogram swimmer on the right. Okay, and both swimmers jump off with a speed of 3 meters per second. So we know a mass for the raft, I believe. The raft has a mass of 180 kilograms. But we don't know its velocity, right? So we have, let's call this swimmer 1, okay, on the left, and call this swimmer 2. So I'll call this S1, S2, all right? So momentum of swimmer 1 plus momentum of, let me fix that, momentum swimmer 1 plus momentum swimmer 2 plus momentum raft, all of that has to add up to 0, since the total momentum before the collision was 0, and the total momentum before has to equal the total momentum after. Okay, so that's the basic relationship. We move this over just a little bit. Okay, so, and this is a vector equation we've set up. Swimmer 1's moving to the left, okay, and that's going to be 150, right? 50 times 3 is going to be 150. That's the momentum of swimmer 1, okay? Momentum of swimmer 2 is going to be 3 times 80, which is 240, right? But that's to the right, and that's longer. Okay, so 240. Therefore, the unknown momentum has to add in here such that these all add to 0. So when placed head to tail, the vectors need to add to 0. So the momentum of the raft, the magnitude of that momentum, has to be 240 minus 150 from my vector diagram. I got 0, 1, 90. So 90 has to be the momentum of the raft. And it's actually to the left. All right, that's cool. So we're almost there. The momentum of the raft then is going to be 90 kilograms meter per second, right? So therefore, this 90 kilograms meter per second has to equal mv, right? And the mass of the raft is 180, so I'll put that for m. And I'll just take out the units. And we already know v is to the left, so I don't need to have this a vector. I can just solve for the magnitude. 90 over 180. That means the speed of the raft is going to be 1/2 of a meter per second. And this is going to be to, if I want to identify the direction, it's to the left based on my vector diagram here. Okay, that's it. Pretty cool problem. Hope you enjoyed it, and have a good day.